Next, we want to look at using the one-to-one property of logarithms, which is very similar to the one-to-one property for exponential expressions. If we have the log base b of 2 set equal to the log base b of x, the only way that can be true is if x is equal to 2. Because inserting x equals 2 would make the two sides of that equation exactly equal to each other. That gives us the one-to-one property, which is that the log base b of m is equal to the log base b of n if and only if that expression m is exactly equal to that expression n. We can use that in example 8. We have the same logarithm on both sides, natural log or log base e. So the only way this expression can be, the only time this expression will be equal is if the expression contained inside those logarithms are equal to each other. Meaning we need to solve negative 3x plus 4 is equal to x. We can do that by adding 3x to both sides to get 4 is equal to 4x, and then divide both sides by 4 to get x is equal to 1. Since we're solving logarithms, we need to check that that value lands our logarithms within the appropriate domain. Since we have two different log statements in the original problem, we need to check both of those. We need negative 3x plus 4 to be greater than 0, and we need x to be greater than 0. Checking the second one is pretty easy. If x is equal to 1, that's greater than 0, so that solution checks out. If x is equal to 1, we would get negative 3 times 1 plus 4 in the first logarithm, which would give us positive 1, which is greater than 0. That checks out. So x equals 1 is a valid solution to this equation. Similarly, in example 9, the base of the logarithms are the same on both sides. So what we need to solve is 5x squared plus 10 is equal to negative 15x. If we move negative 15x to the other side by adding it to both sides, then what we end up with is a quadratic equation. In order to solve this equation, we need to factor as much as possible. The first thing we'll do is look at factoring out the greatest common factor, which is 5. That will leave us with x squared plus 3x plus 2 is equal to 0. Factoring that polynomial will give us 5 times x plus 2, or factoring that quadratic will give us 5 times x plus 2 times x plus 1 is equal to 0, leaving us with two solutions. X is equal to negative 2 and negative 1. Again, those are just proposed solutions. We need to check those to make sure they don't violate the domain of either of our two log expressions. We need 5x squared plus 10 to be greater than 0. First, we'll check that with a solution of x equals negative 2. That will end up being positive since we're squaring the negative value and adding 10. That checks out. And then we also need to check our other solution, negative 1. That will also end up being positive. So both of our solutions work for the first logarithm. Now we need to check that they work for the second logarithm. That is, we need 15x to be greater than 0. Negative 15 times negative 2 is a negative times a negative, so that will end up being positive. And negative 15 times negative 1 is a negative times a negative, so that will also end up being positive. We ended up with two solutions, two potential solutions. We checked each of those in each of the logarithmic statements that we have to make sure we wouldn't be taking the log of 0 or anything smaller than that. We get positive results in each case. So in this case, both -2 and -1 are valid solutions to this logarithmic equation.